Well, hi, everybody. Welcome to our info session. My name's Erica Underwood, and I'm the director of our fellowship program at the Data Incubator. Michael, who will be talking in just a few, is one of our instructors, and I'll let him introduce himself. Before we go ahead and dive into Michael's content, I wanted to quickly just give a little introduction about who we are and what we do, and why we are hosting this information session. So we are the Data Incubator. We operate a fellowship program that particularly works and focuses on data science. It's an 8-week program, and we focus on bringing in students that have a master's or PhD and training them up to work with data in the real world. And why is this important? Because data scientist is the sexiest job of the 21st century. This is something that is definitely necessary in the world that we live in, and it takes all of these skill sets and backgrounds and really requires you to have a knowledge in a lot of different areas to be really good at this. As you can see, the crossover here is software development and traditional research, while also maybe having a background in math or computer science or even some business knowledge. And so that's really where our program tries to take all of this background and put it all together in a way that makes sense and is appealing to the companies that hire from us. So as I kind of mentioned, the fellowship program is pretty intense. It's 8 weeks full time, Monday through Friday, 9 to 5. It's very collaborative. We really foster a collaborative learning environment. We work through Jubair Notebooks, so it's really hands-on, live interactive coding. We also have a lot of group projects in the sense that you are asking questions amongst your colleagues. We're doing lectures with instructors every day. We also have our students work on a capstone project, and this is any publicly known data set that they want to work on. And they create a project that has some sort of business objective out of that. You actually use that as part of your application, and then you work on that throughout the program. And then that's kind of wrapped up at the end of the program. We do a pitch night, and we pick those top projects and have them present to our hiring partners. Our curriculum is very thorough. Each week it focuses on a different data science approach or tool. So each week is a different mini project that we've associated with some kind of topic. So there's 2 weeks dedicated to machine learning. We also do TensorFlow and a variety of other topics too. And it's also very forward thinking. Obviously we want you to learn data science, but we also want you to learn it in a way that helps you go out into the workforce successfully. So we have career coaches that hold presentations about how to interview, how to present well, how to negotiate offers, all of those things that come up that maybe are tricky to navigate. We also do several networking events. I mentioned that pitch night, but we also really try and cultivate environments where companies can connect with you guys outside of that traditional interviewing process to help make those connections. We do bring in 2 different types of students. We have fellows where it's a tuition-free scholarship. Those are very select and a small group of students that are highly qualified. We refer to those as fellows. And then we accept scholars, and these are people who are awesome and amazing candidates too, but they do have to pay a fee. And the difference between fellow and scholars, other than the fee, is that fellows have the flexibility, or do not have the flexibility to look outside of our program. So fellows have to look at jobs within our hiring partner network for 3 months following the program. And that's why the program's for free with them, is that we are hoping we have identified a good match between that person and a company that we work with, and we're hoping that that placement takes place. And so there's not a lot of flexibility for fellows to look outside of the program. Scholars, on the other hand, because they do pay, they have all the flexibility. They can use us as hiring resources. They have access to all the same curriculum and career search resources and job opportunities, but they're not restricted to that. They can look on their own outside of our program. There is a way we help to incentivize you guys to look with our hiring partner network, and that's we do offer a reimbursement on your tuition if you get placed with one of our hiring partners. So that can also help. We also offer a lot of financing options to scholars to help them afford their tuition. Obviously, this is a big step, and we want to make this as easy and as seamless as possible for you guys. So we have a different variety of different options, and those can be found on our website or by emailing us for more information. But the biggest thing that everybody wants to know coming out of our program is what's our placement rates? How do people get employed? And we are really proud of our placement rates. 82% of students that go through our program are employed within 6 months of completing our program. And 97% of our students are currently employed outside of academia. So, you know, you'll hear it time and time again. If you are looking to transition out of academia, if you want to get into that private sector and you don't know how, our program is that way. All of our students know that they are intelligent and have these skills, but don't really know how to transfer them. And that's really the focus of our program, not just on the technical side, but as I mentioned, on the career search side and just in getting opportunities in front of you that maybe you wouldn't know how to find, or getting access to roles that maybe you wouldn't have access to outside of our program. Where are our students working? Well, they're working in 55 different industries, but we pulled some of the top ones. Obviously, computer software, internet, information technology services, financial services, biotech. You can look on the other side and see kind of the roles that people are being placed in. The main role is data scientist, but depending on the company and the industry, it can also be a data engineer or an analyst or even a quant or product manager. So these are many of the roles that our students get placed in after completing our program. We work with a variety of hiring partners. I think we have a network of over 400 companies. These are just some of our ones that we work with to give you an idea. So as you can see, a lot of variety here. We have 3 classrooms in the US. We're in New York, DC, and San Francisco. So a lot of our hiring partners are from those areas, but we do have a lot of hiring partners throughout the country and a couple international ones as well. As I mentioned, you know, we do have a couple different financial assistance. These are just little snippets. Again, if you are interested in learning more, you can email us at admissions@thedataincubator.com. And we also have a website page dedicated to this. But LEAF is an income sharing. It's great. And CLIMB is also a loan that we can offer to those that have a U.S. Social Security number. If you don't have that, then we have a partnership with STILT that offers loans for those non-U.S. citizens or those that don't necessarily have a U.S. Social Security number. So now, after all this, you hopefully are hyped and excited to join our program. I'm going to give you a little information of what that looks like. So right now, we are currently accepting applications for our summer program. The summer program is going to run from June 29th to August 21st, so 8 weeks. And the application is currently open, but it is closing soon. The application closes on May 2nd. You can see other dates there. I'm not going to throw them out so I don't confuse you, but you need to know that the application will close on May 2nd and that it will start on June 29th. What does our application process look like? Well, the first part is pretty easy. You just provide us information, you know, the standard, your name, your educational background, where you're currently located, all of that good stuff. Then we will send you a coding challenge. You can schedule to take the coding challenge anytime you want until May 5th. It takes 72 hours to complete it. So know that once you start that, you'll have 72 hours to complete it. But we do want to be flexible with everybody's schedule, so you can decide when you want to do that, as long as it's before May 5th to be considered for our summer session. After the coding challenge, if your score meets our standards, then you'll be asked to interview with us. This is where you will also present your preliminary work on your capstone project. So you'll be brought into an interview with anywhere between 3 to 6 other applicants. An instructor will be in that, and then a person on our placement and recruiting team. And you'll have 2 to 3 minutes to kind of present to your capstone project what you've done already on it, what you're hoping to do, you know, the objective, where you see this applicable in a business environment. The instructor might ask you some questions, and the placement team is going to ask you some questions on what you're looking for after the program ends to best help, you know, match you up with our opportunities. And then after that, we would let you know if you made it into our program and all of that good stuff. We do host a virtual open house to help answer any of those questions you might have once you get into the program. But that would be on May 20th, so you have some time to think about that. If you guys are interested in applying and you haven't done that before, the website is below. It's just thedataincubator.com/apply. I highly recommend you guys applying. Make sure you do so before May 2nd. But we are really excited to have you guys. We love our program. We love our students. We have a very tight, strong alumni group. So hopefully I'll see you guys this summer. And that being said, I'm going to kick it over to Michael, who will go into his presentation. I believe we might allow some time for some Q&A after Michael's presentation, so we can help answer any other questions you have about our program or the application or anything that Michael is going to go over. So that does it for me for now. So I leave you in Michael's capable hands.
All right, thank you so much, Erica. And if you could pass over the presenter thing to me, and I'll get started with screen sharing in just a moment. And while you do that, let me just say welcome, everybody. It's like we have awesome turnout today, so I'm super excited to share this with you. A little bit about the topic of today's talk before we really get into the sort of the content of it. Today we're going to be talking a lot about how we collaborate with code, especially in a data science setting, and sort of the tools that make that collaboration get rid of all the friction, as much friction as possible, that make it productive, that make it fast to iterate, and also really specifically we're going to be honing in on ways of collaborating with non-data science practitioners, how we can quickly exchange information or iterate on projects with, team members who are maybe, in a more business role. We're going to be talking about sort of some of the motivations or some of the more conceptual techniques around doing that. But we're also really going to be demoing a lot of the tools that make that possible. So all that being said, I guess I'll go ahead and get into the actual content. So let's see, screen sharing going on. Let's see if I do this. I move this. Just trying to move this toolbar. Sorry. All right. And Erica, could you confirm that you can see the window?
Yes, Michael.
Yep, you're all good. Sorry.
I just wanted to make sure so I didn't, get started without it. Cool. So we're going to be talking a lot about a tool called Binder today. And Binder is a really phenomenal way of deploying interactive Jupyter notebooks. I suppose I should step back just a little bit before I do that. And so let's talk about Jupyter Notebooks. Many of you have probably seen this format before, but for those of you who haven't, Jupyter Notebook is a wonderful resource for basically blending interactive modular code. So we can write code in all these little cells. We can run them separately, really in whatever order we want. We can have interactive code. We can have nicely formatted HTML text and tables and images, and really all sorts of things. And we can even write in multiple programming languages within the same notebook. So for instance, in this cell, I'm actually writing a bash script to download some data. And it is, Jupyter Notebooks technically are a front end for doing this. They give us sort of these nice graphics. Technically, this is built on IPython notebooks. But in any case, these are, like I said, I reach for these all the time. Whether I'm giving lectures like this, I'm doing exploratory analysis, or sort of the topic for today is maybe I'm passing kind of lightweight tools for my collaborators to use so that I don't have to build out too much, in terms of like a web framework or anything like that. Just quick interactive tools for, processing data, getting predictions, getting reports, and all that kind of good stuff. Now, a little bit on, getting, these resources yourself. If you don't have them already and you're interested in working on, this sort of from the data science role, kind of doing what I'm doing now, I want to point out just a few things. First off, to run these on your local machine, the easiest way to do this is to get you're going to need a Python distribution, and you're going to need to have Jupyter installed. Now, a great way to do that is simply to get the Anaconda distribution. We sent this out in the email as well. And so this is just basically a whole bunch of sort of standard Python packages and a Python distribution, all just sort of bundled together. So just anaconda.com, the individual distribution, kind of comes with everything you need. It comes with Jupyter, it comes with Python, of course, and it comes with what we'll need for virtual environments. Now, why do those matter? What is a virtual environment? And this is going to get us a lot into sharing results, but perhaps I'm getting a little bit ahead of myself. This notebook I have here is the sort of thing that I would put together as I'm exploring a data set, basically looking for particular insights or starting to build some basic models, toward accomplishing a particular goal or informing a particular type of decision that we need to make in business, right? Because ultimately, whatever we're doing in data science, we're trying to get a better idea of what happens or what we should do when we make a decision. Those kinds of decisions really are at the heart of this field. If it didn't inform what we needed to do, then why would we be studying it, right? And so the problem I'm working with today comes from this publicly available data set. So University of California at Irvine, I believe, has a fantastic basically repository of machine learning data sets. I would recommend just look up UCI machine learning repository. They have all kinds of data sets and all kinds of topics and with different sort of numerical properties. But we're going to be working with this news popularity data set. And what this contains are about 100,000 news items on 4 different topics. We're going to be sticking with the ones that are relating to Microsoft. And, in addition to information on those articles themselves, we have social feedback on 3 different basically social media platforms. So we can see how popular that article was on Facebook, Google+, and LinkedIn. And we might imagine why this is important for decision making. Get to that in a second. Just a little bit more on the data dictionary. So we have this news data data frame essentially. This is going to give us an ID for news items. We'll have a title and a headline, of course, where it was published from, what topic. Again, we're just going to be using ones for Microsoft. When it was published, some sentiment analysis actually on the title and the headline, and then the final scores for popularity for those 3 websites. Now we have these additional data sets. I download them for today's lecture. I'm not actually using them, but we can talk about using them to iterate, which tell us over 2 days after publishing something, how much more popular does it get? What is the sequence for popularity, that time series of how popularity grows for a particular article over 2 days. So again, this is what we're going to be working with. We're going to be doing a little bit of machine learning to make some predictions on the popularity for each of these websites. Okay. Now, why does this matter? Well, we could imagine that I'm working with the marketing team, maybe the social media marketing team, and they are trying to decide their, budget for an upcoming period. And perhaps they need to think about strategizing around, should we really be putting money into promoting posts on Facebook or on Google Plus or on LinkedIn? Which of these do we see the most popularity sort of organically? Which of these do we benefit from promoting? Which of these drive other goals and KPIs we have? But we're just attacking a small piece of the puzzle today, which is, can we know ahead of time how popular a post is going to be once it's shared on some social media platform. That's really what we're going to be looking at, because if we're going, if we have some news article, and perhaps it's something that we want to promote, if we have a good idea of how well it's going to do on Facebook versus Google Plus versus LinkedIn, that's going to inform our strategy for budgeting, right, around promotions, around marketing. And so that's kind of the question that we're going to be examining today. We're going to be just doing a little bit of data science around that. Now, I'll be going through this on my screen. I will say now that so we can sort of start making use of one of these tools. If you would like to follow along, go ahead and go to mybinder.org, and I'll probably paste this link into the chat box as well. This is the platform that we're going to be dealing with for the most of the second half of today's lecture. mybinder.org is a website and a Jubair Notebook deployment kind of framework that lets you take any Git repository and just someone can fire it up right away from any public Git repository. So mybinder.org, and I'm going to paste this link to my Git repository into the chat as soon as I find the chat. So github.com/mcullan, that's me, /collaborating with binder. So you would go here, you would paste that in this box right here, and you would hit launch. Now this may take a few minutes to get going. Actually, it looks like the image is already built because I had made it a little while ago. And this way you'll be able to follow along with some of the stuff we're doing. Okay, so once we're in here, we just have a few things to do to get started. I'm importing some libraries. I'm going to be downloading the data. Now, I've already downloaded them, so they're not going to download again. And I'm going to just start preparing the data to do some analysis. So I'm reading in those CSV files. I'm setting index columns. I'm restricting it so we're just looking at Microsoft. So I'm going to run these. Let's see. And we can take a look now. We can look at our news data frame. And so here we have a bunch of articles and headlines, where they were published, when they were published, sentiment, right? And we see that for the Facebook, Google Plus, and LinkedIn columns, we have a lot of these negative ones. And it turns out that these columns, if we see a -1, it means that it was actually never posted to this site. Now, we don't really want to deal with that. We want to know how well is it going to do if it's actually posted. So I'm going to get rid of those rows. So we're just going to go ahead and restrict to those articles. I'm not going to go through much of the syntax of this code. But now if we look at this data frame again, they're at least 0. If they're 0, they showed up, but they didn't get any traction. That's okay for us. Okay. Now we're going to be using these sources to make some predictions. As a result, we don't want to predict something about a source if it has like very few articles. So just for kind of something I just sort of decided for this particular study, I said, let's just use sources where there's at least 50 articles. And again, where they, did end up on all the sites. So we figure out all the sources that have 50 articles or more. Turns out there are 75 of those sources, and we're going to restrict just to those ones. Now, there's a little bit more we have to do before we get ready. We're going to look at the data again. So we have this published date column. Now, this, of course, tells us when, the day and time that it was published. But we want to make sure we can actually use that to pull values out of it. And then we're going to make some new features for the year, the month, the day of the week, and the hour of the day. And so that's what I'm doing right here. Again, I'm not going to get too much into syntax. And then I'm going to basically split off. I'm going to say, okay, maybe we had some historical data that we were training on. Let's say this was everything from the start of the data set to like the last month appearing. We're going to hold off that last month and say, this is our testing set. And really, we're kind of thinking about this in terms of, well, this is our testing set, realistically. So we have data we're training on, kind of our historical data. We have data where we want to use this in application, which is going to be our testing data. So I'm running those. I'm just going to save those to a CSV as well. And now, before we get into machine learning, let's talk a little bit about just sort of a couple of investigations we might do. Again, very exploratory here. Nothing too polished, just so that, as we're performing this analysis, we could just start seeing a couple insights. So again, we'll take a look at the data. Now we have these month, day of week, and hour columns, so that's awesome. And I guess I can change this. So let's say we wanted to look at the, when these articles occurred, just to kind of see, what does our data really look like? And so, here's mostly 2016, a little bit of 2015. We could look at when in the week are these published. And so if we do this, we see that, interesting that zeros over here. I guess they're put in order. So 0 through 4 here, this is going to be a 0 index for Monday. So 0 is Monday, 4 is Friday, 5 and 6 are the weekends. So we're seeing that we have a lot more stuff getting published on the weekends, or I'm sorry, on the weekdays, which is really not surprising, right? Okay, now let's take a look at, this should be like that. Let's take a look at our, how we're doing in terms of sentiment. So here's just a little plot where we can kind of see, right, we have all these kind of little kind of translucent circles, and as they stack up, we get the idea that there's a lot more density in that area. So it looks like sentiment generally, here we have the average, this dotted line, pretty much right on 0. So looks like there's about as many, negative sort of things being said as there are positive. And it looks like, mostly, again, centered around 0, kind of looks probably like a normal distribution, with some, getting into the tails a little bit as well. Perhaps some of the one really negative one, but, generally, again, that's probably an outlier. We could test that if we really wanted to. That's for the titles. Of course, we could do this for the headline as well. So we would just replace this, right, to say headline. And again, just to keep getting an idea of, how these work. So now it looks like maybe we have a little bit more, well, on average, maybe a little bit more negative, but some kind of greater outliers on the positive side. But again, just sort of seeing what some of these features look like. So based on this, I figured let's get right into modeling. What I want to do is I want to predict, like I said, Facebook popularity, Google Plus popularity, LinkedIn popularity, based on the available information that I have. Now, I'm going to be doing this in a pretty simple way. We can talk more about the sorts of feature engineering that I might want to do in a future iteration, but that's sort of, a next step. Here, we're just seeing if we get any, really, if we get any signal at all, right? So I'm going to bring in some of my typical tools from scikit-learn, kind of, the machine learning library that we use pretty much any time we're doing standard machine learning in Python. And I'm going to build a little transformer. This just allows me to take the data frame and just get the columns that I want. So I'm going to define my data frame just to save a little bit of, really just to save a little bit of typing. And I'm going to get rid of a couple of things. Since I already have the year and the hour and, things like that, day of the week, I'm not super worried about the actual date it was published. This is not really a good object for scikit-learn. I'm going to get rid of the title and the headline as well, again, because these are text. We don't really want to deal with that. I'm going to create a couple pipelines. And again, I would love to get into how we're doing this in scikit-learn, but I'll just describe generally what happens here is I'm taking all of my sources, those 75 different publishers, right? Those newspapers and websites. And I'm saying, okay, from all of those, I have 75 of them. Let's just sort of label each of them with a number. Or let's make 75 new columns. And if it's in the first source, we'll just put a 1 in that column and a 0 in all the other ones. So one hot encoding. Essentially, like I said, just takes these categorical variables, makes them a little bit better for using them numerically, in a linear algebra kind of way. So I'm doing that same thing with the hour of the day. So I'm treating every hour of the day kind of as a separate category. Now, this is not always the best way to do it, but again, we're looking for any signal at all here. We can get into more feature engineering as we go. And then I'll make another one that just grabs the sentiment for the title and for the headline. So we're going to be making predictions on these three things. Where was it published? What time of day was it published? And how positive or negative are the titles and the headlines, right? That's, again, what we're working with. I'm going to take all of those. We now have kind of all these different, matrices, tables of columns floating around from these transformations, and I'm just going to smash them all together into a big new feature union matrix. Use that matrix to make predictions. So now I'm going to build this linear regression model. I'm going to do that with each of the websites. So with one model, I'm predicting the Facebook popularity. With another one, I'm predicting the Google Plus popularity. And with another one, I'm predicting the LinkedIn popularity. We're going to fit all of these to the original historical data. And of course, we're trying to predict that popularity, right? So same for all three of them. What's next? Well, of course, we lose the Facebook one. I guess we did. Sorry about that. After we train these models, what we want to do is we want to see, of course, how well they work. And it looks like I lost one of my cells here, so I apologize as I have to live code a little bit of this. And when we evaluate the performance of machine learning models, we typically are looking at a score, an error function, things like this. Here we're going to be looking at R squared. Again, I can't get too into the details here, but we want to know how well do these models do on the data that they learned from compared to new data that they haven't learned from. There's a few reasons we do this, of course, as you may have heard before. But if we ultimately we want to build this tool so that we can learn something about the future, right? We want to know how popular something's going to be before we get a chance to observe it. So clearly, we need to think about new data. As such, we definitely want to make sure that this still works on new data, but also we want to make sure that we're not memorizing something in the old data that isn't actually going to be applicable in the new stuff. So we want to compare how it did on the model, on the data that it learned from, to new data that it's never seen before. And that's what we're going to do here. Now, for each of these models, we're looking at the R squared. I will say right off the bat, the Facebook model is doing very poorly. An R squared of less than 0 means that we are worse off using this model than just guessing the average popularity of a Facebook post for us. But again, we can always revisit and try to improve the models. For Google Plus and LinkedIn, we're doing considerably better. We're getting some signal for sure, doing better than we would by not using the model. And we have a little bit of validation. Really, at this point, I would go back and do some more modeling, but we want to think about what we're using these for and how we're using them. So what I'm going to do now is I'm going to make some predictions for how well we're going to do on all of these websites. I'm going to just put those predictions back in the data frame so we can do some comparisons. And let's just take a look at what these results look like. What's missing here? Google is not an index. It's because I keep doing this. So now we can see, a couple of our articles that are upcoming, right? They're starting where we started that new data frame. And we can see that, we're making some predictions for Facebook, seems pretty close. Google Plus seems pretty close. LinkedIn, now I would point out here that we are now making negative predictions, which is not really a good thing for us. We could have also done some transformations of these label values to ensure that we weren't going to make negative predictions. But again, just kind of taking a coarse approach here. So one thing we might want to do now is we might say, I have all these separate models. If I could convince myself that they were really doing well, then maybe I could use the outputs of those models to just try to figure out where we're going to do the best, where we're going to do the worst, maybe how much better or worse we're going to do, and start using those to drive some decision making. This is sort of future work, sort of thing we would follow up on after we bring some preliminary results to our collaborators. And all that being said, why don't we talk a little bit about how that collaboration works? Okay, so these are kind of the results I want to share at this point. And so what I'm going to do, I want to use Binder so anyone can just fire up this notebook on their browser and use it right away. So I'm going to make a Git repository. I'm using GitHub for this. This is really the most common Git framework, or I guess website really ever used. And we make a public repository. This is going to contain the notebook that I'm working from, this IPy notebook file. It's going to contain, it also must contain something called environment.yml, or I guess also requirements.txt. These are both okay ways of building a Python environment. And what this file is, we can take a look at it. This is basically a recipe for all of the things that we need to run this notebook. We have a name for an environment. We have some places we might install from. And we have all of these cool packages, like pandas is what I was using to make those tables, scikit-learn that we're making predictions from, all that kind of good stuff. And we need that recipe because when we go to mybinder.org, go back here, and we put in the link to that GitHub repository, it's going to look at that recipe. It's going to look at environment.yml, pronounced YAML actually, and using that recipe, it's going to build basically a container, kind of like a virtual machine, something that we can run the notebook in. Now, in general, the reason that we need these sorts of things, if we're running a piece of software, whether it's a Jupyter notebook or an app or anything, on multiple machines, we want to make sure that it does the same thing on all of them. Perhaps this is you passing code between you and other data scientists you work with, in which case you're doing a lot of programming. You want to make sure that if you're using pandas, they should have pandas. If we wanted to be really, really specific here, we could specify the versions, the releases of these. Again, to make sure that everyone is doing the exact same stuff. And of course, with Binder, it needs that recipe because otherwise it has no idea what it needs. And so these virtual environments, which basically just package up everything you need for your software, indispensable tool for collaborating directly with other programmers or scientists, as well as collaborating more indirectly by giving these Binder notebooks what they need to run. So that's a little bit on what's going on in the GitHub repository. I guess I should have tried to fire this up. Like it's not super happy right now. Should be launching. Now I've been running this notebook on my own machine, but it would run just the same on Binder, perhaps maybe a little slower. Cool. So yeah, here is our file directory, right? We have this exploratory notebook. I believe that the outputs are probably in there right now, which is fine. We're going to clean them out. Say restart and clear output, that'll get rid of everything. But just like before, we can run these just like we already did. We'll be able to download the data. Now, this is actually why I used Bash to download the data, because it would be inconvenient for us to have to, click and drag and manually upload things. We just want it to work. So kind of a side point, but if you're ever doing this kind of analysis, it's very helpful for your collaborators to do something like this so that everyone has the same data in the same place, basically automatically. And so this is what anyone would see if I sent them this link. So let's say, for instance, that Erica was, my collaborator on the marketing team. And I said, all right, if you want to see kind of, what I'm starting to do here, I'll send you this notebook. Just keep hitting shift, enter, shift, enter, shift, enter. At least, some of the visualizations and things like that, you'll probably be able to pick up some of what I'm doing. And then we kind of go from there. Now, perhaps we get to this point and she says, okay, it looks like you're kind of doing something decent with the models. What we really want is for you to tell us which one is going to do the best. Then I would say, okay, I can go build that out. Or which one is going to do the worst? Okay, I can go build that out. But again, being able to pass these results and being able to pass them to non-programmers in a way where they don't have to download Python, they don't have to set up Conda, they don't have to open Jupyter, they don't have to use a terminal on their computer, none of these kinds of things. It just makes it so that we can really get right to business. Cool. Another thing that we could even do, from this Binder deployment, we could even go to upload. And maybe from here, we have a new CSV of this week's articles or today's articles or something like that. And if that were the case, we could upload that directly to this container and we could make predictions on the new articles. So this means that just building a notebook like this can actually be a really lightweight tool that your collaborators can actually use. And so if you're like me and you don't have a lot of experience building web applications, you might spend a lot of time making something that someone can use, maybe more time than they actually end up using it or more value than they get from it. You can make these little lightweight tools that can really get a lot of good stuff done. Okay, now, kind of my last point here, before I turn things back over and take some questions as well. Let's say from what we've gone through so far, Erica says like, okay, great, this is looking pretty good, but to get more clearance for you to put more time, or maybe to open up other team members to work on this, or maybe to spend some money on this, I'm gonna need to show this to my managers, really whoever has that decision-making capacity. And so, is there any way you could put some of this stuff together into a presentation form, maybe like a PowerPoint? You can say, sure, I could do that. Or another thing that we could do, and this is one of my favorite tools to show off, is we can actually turn this into a slideshow that has interactive code. I love showing this stuff. Now, here's how I'm going to do that. Let's say I don't want to modify the original file, the original master file, or maybe I'm doing some other changes as well. What I'm going to do is I'm going to go onto this Git repository. I'll probably do it through the terminal, but I'm going to make a new branch. And in that new branch, I can change some of the files and I can update them online, but I don't have to actually change the master one, that if you just downloaded this or ran this, you would get the master copy. This is sort of changes that are kind of on the side that we might approve and mix back into the master, but not necessarily. So I open up this new branch. The way that I do that, let's see. Actually might be on, just one second. So I'm running a terminal here through Jupyter, again, on my local machine. So from the browser, Jupyter browser, I went new terminal. This just lets me access the command line, which is not the only way to use GitHub or to use Git, but it's my preferred way. I'm just going to do a few things here. I suppose I need to get rid of these CSVs. Sorry, just as I kind of do a couple preparatory things. This is a very inexpressive Git message. Don't do this when you make commits. But I just want to get back to kind of the appropriate starting point for when I was going to make this branch. So if I look at my Git status, I'm on the master branch right now. Again, if I make changes and I push them to the website, these are going to actually change that master copy. I don't really want that. What I actually might do is I might make a new branch. And again, this lets us make changes that don't reflect in the master copy. I'm going to git checkout, check out a new branch, -b, call it slideshow. Seems reasonable. So I'm on this new branch called slideshow. And in here, I will go ahead and open this notebook back up. And I'm going to basically make some edits. Now, I'm using a package here called Rise, R-I-S-E. That is what allows us to do these slideshows. So that was in, actually, if we were to go back to my, I know I'm jumping around tabs here a lot, but we've installed this package called Rise, and that's because I wanted to be able to do a slideshow. Maybe at this point, I would have had to change the environment to add that if I hadn't already. Totally another thing we can do. Again, the power of virtual environments, so that we can make these changes as we need them, and everybody has the same thing. Okay, so I'm back in here, and I'm going to open up this toolbar for slideshow. Now here we see there's a bunch of slide types. Maybe we'll make a title. That's probably a good thing to have in a presentation. And let's say predicting article popularity on Facebook, Google+, and LinkedIn. With machine learning. Yay. So what we do now is we actually specify this cell should be a slide. Let's say maybe some of these cells, we don't really care if people see a lot of the really code stuff that doesn't give us results. So we'll go ahead and we'll just skip a lot of these. So as we're going to just go down, and I'll set up just a few of these, and we can demo what this is going to look like. So again, I'm going to skip a lot of the sort of pre-processing, loading, just sort of the overhead that we're doing. Skip this one. Now maybe I will run, oops, yeah, skip. Maybe I'll run this one because we can see, a little bit about the data we're using. I could have done similar things on the previous steps as well. Probably skip the dates parts. There are keyboard shortcuts for this as well. I don't remember what they are, but there are much faster ways of doing this step. Maybe make a slide for, and let's look at maybe let's say descriptive analytics, something like that. It maybe sounds a little bit more official. Make a slide for this. Now, what we'll do here is we'll just pull up our data one more time so we can look at it again. And we'll start, showing these visualizations. So we'll get through all of this. We'll skip this one. We'll skip this one. And now we have machine learning. And we'll skip all of these probably until the very end. Now what's going to happen is when I activate the, when I take this to the slideshow mode, everything I set to skip, it won't show in the slideshow, right? Probably makes sense. And everything I set as slide or sub-slide or fragment, we'll see kind of how those show. And once again, I guess because I've been switching branches, it's kind of causing a little bit of trouble. But this is close enough. Okay. So now we're back here. And with the press of a button, I'm going to hit Alt-R. And doesn't seem to be very happy with Alt-R. So that's interesting. I think I'm not running on the yeah, it was actually, I'm sorry about that. I was actually running this from the wrong virtual environment after all of my talk about how great they are. So I'm just going to reopen this notebook on the correct environment. All right, so coming back here, it'll open in just a moment. So we'll get this notebook opened back up. I'm now running the same notebook, but with a different set of libraries, the ones that were installed by that recipe. And it autosaves, so it still has all my slide types. So this time, for all the marbles, Alt-R, taking us into this awesome slideshow view. And here we can start going through with spacebar. We can look at some of our code that we've been running. And these are still interactive. And it's mad at me because I didn't run the preamble cells. But we can go through all these results. We can really put them. 3 should be more slides after that, unless it didn't autosave. No, it looks like it ran out. Okay, well, in any case, this is a sort of quick example as to how Rise can be used to do a lot of really cool stuff. I'll end this part, I guess, after just showing these two plots. So from Alt-R, it switches us to the slide view, still interactive, still has everything we want in there. And we can simply, we can show some slides. This is going to be a sub slide where this is a new slide, seeing how some of this code was written. We can, look at kind of what our data looks like. We can pull up, the year that it was published, look at the day of week that it was published, and we could have kept going through all of that as well. So there's so many different things we can do here, and all of these can be used by our collaborators. They could just show this presentation, or we could make a tool that they could use, or they could say, can you make these changes? And we could get right to work without having to really pass anything back and forth. Again, especially if we're collaborating with people who they're not doing this kind of programming, and it's just faster for them to take a look at it and kind of get back to things. So this kind of wraps up the bulk of today's lecture. I know we did a lot of things very quickly. We went through a little bit of exploratory analysis, making decisions with machine learning, who those decisions matter to, the sorts of tools we use to build these things, the places that we might host these things, the places we use to share these things, and just sort of all of the other pieces that make that possible. I suppose the last thing I will point out, so with Binder, we saw this awesome way that we could actually send someone something and share it with them. But on GitHub, we still have this Jubair notebook, IPython notebook file. So why can't we just do it here? Well, if we open this file in GitHub, we see that we still have that kind of nice HTML. We can still see what, that's a fun one. So one reason is that we can't minimize cells. But most importantly, we can click in here, but we can't run any of this. It's not interactive. It's just static HTML. And so if you want people to be able to work with your code, then we have Binder. Binder has been used in a lot of different settings. It's becoming very, very popular in academic research. Of course, reproducible research is always a big deal in the scientific community. Someone else should be able to get the same results as you with the data that you had. It's becoming very popular for educational purposes, for business purposes, and so forth. The applications really are endless. Anytime you want to show somebody how you did something and let them run it themselves, Binder is a phenomenal tool to reach for. The only caveat is that we required this to be a public repository, because when we were on mybinder.org, we had to paste that link in, and Binder had to be able to grab everything it needed from that repository and build this thing. And so, as a result, we have to ensure that we have the right, that it can access it. So that means that we have to have public code, which likely means that if we're downloading data from anywhere, we have to worry about, is there sensitive data involved? If so, maybe mybinder.org, the public deployment, is not a great choice. However, with any sort of big cloud provider or even our own server that we run independently, we actually can make a distribution like this, and we could launch Binder notebooks, with authentication, whether it's just a username, password, or a Google account, or whatever we want. There are a lot of ways of customizing this deployment if we have our own backend. And perhaps in a future talk, I might be able to present a little bit about building one of those on, let's say, AWS or Google Cloud, but that really is a conversation for another day. It looks like I've gone on for quite a while at this point. One more thing I will mention. So I had opened up a new branch in that repository, and I didn't commit anything to master. So if we wanted to, we could actually just put the name of the branch in here, and we could open up a Binder notebook that is coming from that branch, not just the central, not just the overall master copy of the code, but if we're making changes that we don't want to commit yet, and we want to show them to our collaborators, we can actually push them to that branch. And if they just type in the name of the branch, they can open from there. So a lot of possibilities, again, just enables a whole lot of newer and faster and better ways of working together. I'll take some time for questions. I know a lot of that was very quick, very fast, so I'll check the chat box, and if anybody wants to ask any quick questions about this stuff, I know it's a lot of material, so just let me know anything you are wondering about. All right, Erica, looks like you're talking, but you are muted.
Oh, thank you. I do that all the time. I was saying, thank you, Michael. That was an awesome presentation. Would you mind go ahead and just give me the presenter? I'm going to put a page up for people to look at while we are answering our questions. I can't hear Michael now.
I muted myself. There we go. It looks like you are back to being presenter now. I think maybe Sarah might have switched you over.
Okay, awesome. So that being said, Michael, I did see some questions come in from you, and I assigned them to you. I don't know if you see any of those popping up, but
yes, I'm just monitoring the chat instead of the Q&A. So I'll start going through those.
Yeah. In the meantime, a couple of common themes that I've seen just in the questions about the program that I'm going to quickly go over. We do this session 4 times a year. So if the summertime is not good for you, we also are doing a fall cohort that starts at the end of September. The application deadline will be in July, but you can check our website at any point to see any information there. And those are the 2 that we have left in 2020, but we will do them in 2021. We do them every quarter. So we do a spring, summer, fall, and winter cohort that last 8 weeks. So you can absolutely apply again if now is not a good time or you don't end up making it into the program or can't participate. The other thing I will say is if you have any questions specifically about your application, or if the program's a good fit for you, or you didn't get the challenge, or just any complications or specific problems, please reach out to us at admissions@thedataincubator.com, and we will be happy to look into that and specifically talk to you a little bit about your situation. The other thing a lot of people are asking, is this recorded? Yes, we are recording this. If you want access to this recording or the slide deck that I shared in the beginning, you can email us at admissions@theincubator.com, and I will send you the link to the recording. Michael, you have any questions you want to answer?
Yeah, absolutely. And I'm seeing a lot of really great ones come in. So I will probably keep, I'll try to address as many of these as I can briefly, so maybe a little bit of a lightning. So a question came in about if there are lecture notes for this. The recording is going to be the best way to, go back through everything. A question that I wish I knew, because I'm not really sure either, how Binder can afford to host all these notebooks or to run all these containers. I wonder that myself. Another good implementation, every user running in the same kernel, or do different users have different kernels? If this means the Python kernel Jupyter is running on, they will be separate because they're going to be in separate, and this is always, I get a little dicey on Docker terminology, but I know that there are multiple containers and each user is in their own container. So, we build a little container with Docker, the notebook runs inside of that. Private GitHub repositories on Binder, I mentioned this sort of at the end. This does not work on mybinder.org, but if you have your own deployment, it certainly does. There are details on mybinder.org and the Binder project as well that talk about doing that. Tutorials for building them on most of the major cloud providers. This method versus Google Colab. I will say I don't have a lot of experience with Google Colab. I think they're pretty similar, but I think that Binder might be a little bit more lightweight. Another good question, probably to round out some of the more Binder stuff. 2 of these are actually kind of related. So one person asked, do we require those Python notebooks to be checked into the repository? Because when you run IPython notebooks, they generate a lot of annoying little files like cached results and all these kinds of things that make it annoying in a git log and pushing these things. So I believe that you need IPython notebooks for this, or Jupyter notebooks, because Binder is running Jupyter Notebook. But to answer a slightly different question, or to bring in this other question, we have this .gitignore file in the repository. And this lets us specify a whole bunch of rules for leaving stuff out of our repository. So I set it up so that none of that other annoying stuff that Jupyter notebooks make, none of that gets tracked by Git. It's still in my directory on my computer. It still would get generated, in Binder or anywhere else we were running it, but it never gets seen by Git. We don't have to worry about pushing it to GitHub or anything like that. So gitignore lets us avoid pushing files we don't want to push. I also could have set it so that none of the data would get seen by Git. So nothing that's like a CSV. This is great if you have data in the same directory as the project. But obviously you don't really want to push data to GitHub because it doesn't like big files, really. It's just not a very convenient way of doing it. And so that kind of rounds out, I guess, my Binder questions. Who's asking, can we share the link to the Binder one more time? Actually, got it to work. Cool. So 2 quick questions, kind of the same question, about the fellowship. Prereqs for coding and math, what level of programming is needed? I'll address the math part first. My background going into the fellowship, and almost all of the instructors were attended the fellowship before they became instructors. My background was in pure mathematics and statistics. So in undergrad, I studied very abstract math. My master's program, I studied statistics from a pretty theoretical level. And I had a couple of years of research of programming in R. I was a very comfortable and competent and fluent R programmer. I had almost no experience in Python, although the entire course is taught in Python. I found it very easy to switch over. But again, on the math side, we are generally expecting applicants to have a reasonable background in linear algebra, in basic probability theory and statistics, and many of the sort of associated subjects, calculus, of course, we need for probability, and things like that. But really the bulk of it is understanding linear algebra, being able to read linear algebra notation, basically matrix multiplication, thinking about matrices, multivariable calculus a little bit, probability and stats, definitely a big one. And then on the programming side, we've definitely taken people who have a range of programming backgrounds. Some people are really, really heavy on the math, not as much programming. Some people are coming in from like computer science PhDs, software engineering roles. So we take a wide range, but overall, being comfortable with like basic computer science, a decent understanding of algorithms, some experience in Python is always good. People who have a lot of R, that ports over very well. People who have other languages often are probably really set to learn Python. If you're good at like C++ or something, you're probably going to find Python very simple. So overall, I mean, the sorts of prereqs that would be good to get into if you're looking to prepare for an application. Again, like studying things like linear algebra, doing intro to Python courses if you don't have those so far, which actually maybe is something that we could plug a little bit. Erica, if my understanding is that we have a couple of free sessions of our intro to Python course coming up online.
Yes, I think one took place yesterday, but I think there are more in the pipeline. So if that's Sarah might know, so Sarah, jump in if you do. But if that's something you're interested in, you can email us at admissions@thedataincubator.com and we can connect you to where you can sign up and participate in those.
Yep. Yeah. So just I guess the last thing I kind of wanted to mention is that there are, we have some other resources as well that are a great way to get started.
Yeah.
And I think that's it for me for questions. So I'll pass it back to you, Erica.
Yeah, lots of questions, lots of good stuff. And this was a very, very quick info session. So thank you guys for your patience as we tried to answer all of them. If we didn't get to yours, please feel free to email us at admissions@thedataincubator.com and we will be happy to answer those. Again, if you want the recording or the slide deck, you can reach out to us at that email address as well, and we can get you the copy of that. A couple of things I just want to highlight really quickly. A lot of questions about requirements. I know Michael kind of went over the technical requirements. As far as school is concerned, we do require you to have at least a bachelor's degree and be working on a graduate degree, meaning a master's or a PhD, to be eligible to participate in our program. Our preference is that you are close to finishing that degree, only because that helps the transition from academia into the private sector for any roles that are available with our hiring partners. They're looking for, they have immediate openings. These are not openings that'll be there in a year or two. So we really like to work with students that are in that transition time period. We don't limit it that. You can absolutely apply, and we'll try and evaluate on a case-by-case scenario, but that's really our thought process. Is we want you to be coming into our program in a place where you can focus on your career development after our program and really work towards those goals. The other thing we're getting a lot of questions on is international students. Since most of our hiring partners are located in the U.S., many of them you don't have to be located in the U.S. to participate in the program. But one, we do teach on Eastern Standard Time, so that's something to think about. We do require all of our students to be in our sessions and lectures and group meetings and office hours and all of that stuff live. So if you're comfortable with an Eastern Standard Time, then you can participate. The other thing to keep note is that most of our hiring partners are located in the U.S. and will want to work with students that are at least authorized to work in the US. So that's something to keep in mind. We do have companies that sponsor visas and stuff, but they would require you to at least have some kind of authorization there. I'm trying to think if there's any other last minute questions. The other thing I will give an update on really quickly, a lot of people are asking how we are handling COVID-19. That's a great question. So for those of you that don't know, our spring cohort, which we are currently in the middle of right now, we moved online for the safety of our students and our instructors. We were really hoping that by our spring session, we could resume back to in-person classes, but we have, for the time being, moved the summer cohort online as well. We just want to prioritize everybody's safety. We are going to keep monitoring the situation. If it gets to a place where we can open up our classrooms and have students in the classroom and social distance and that feels safe, then we will absolutely do that. But for now, our summer session is going to start online for everybody's safety. And that might change over time if we're able to do that. Michael, you had something you wanted to chime in really quick.
Oh, I was just going to say that I checked the next Intro to Python course, and I put this in the chat as well, but anyone didn't see it in there. We'll be doing another free Intro to Python course next Tuesday at 1 p.m. Eastern. I believe slots are limited, and we don't often offer this for free, so definitely, if you're interested, take a look at that soon. Contact admissions at Data Incubator, get the the link and the promo code and all that stuff. And I hope to see you there.
Thank you guys. We went a little bit over, but hopefully we answered most of your questions. We hope to see you guys soon. Hopefully you apply for our program. We're going to be doing more webinars like this. If you're interested in getting on a mailing list, you can email us and we'll let you know when we're doing our next one. But we love doing these. It's a great way to connect with all of you guys. So appreciate you participating. Again, our email is admissions@thedataincubator.com. So reach out to us for any questions that we didn't get to, and thank you all for your time.